first an introduction as to what a hydrated crystal is. A hydrated crystal, they're really actually pretty cool. It looks like a powder and it looks really dry, but if you heat it, you'll see water leave. If I were to, an example of a hydrated crystal is barium hydroxide octahydrate. The formula shows the barium hydroxide part, and then it shows a dot with an attachment of 8 water molecules. Within this structure, for every 1 barium hydroxide molecule, there's 8 water molecules stuck inside there, inside the crystal structure. This whole thing is referred to as the hydrated crystal. This part here, just the barium hydroxide, is referred to as the anhydrate or the anhydrous salt. You obviously know that this is water. If I were to heat this substance, at the beginning, before heating, everything is present. As I heat it, the water's going to leave. And then the anhydrate, or the anhydrous salt, which literally means without water, is left behind after heating. We're going to use this concept to attack our first practice problem. Here's an example for us. 1.62 grams of hydrated cobalt chloride are heated until 0.88 grams of residue remain. We're going to find the formula of the hydrate. So when I say find the formula of the hydrate, we're going to want to have something like this. COCl2 dot some number of waters. That X represents how many times more moles of water I do have than moles of cobalt chloride. So the 1.62 grams, I have 1.62 grams of the COCl2 dot XH2O. I have 0.88 grams of residue. The residue is what's left behind after heating. What's left behind after heating? Just the COCl2. If I want to find the ratio of this to that, I'm going to need to know which one's moles, which means I'm going to need to know each one's grams. How can I find the grams of water? Well, if this is what I started with, and this is what I'm left with, the grams of water must be the mass that disappeared during heating, or the difference in those two numbers. 1.62 minus 0.88 gives me 0.74 grams of water. From this point on, it's really similar to an empirical formula question. That is, I have grams of each. I'm going to get moles by dividing by molecular weight, and I'm going to divide by smallest to get the ratio. Okay, for cobalt chloride, the molecular weight, cobalt is 59 plus 2 chlorines. So 59 plus 71 is a molecular weight of 130. So to get the moles of cobalt chloride, I'm going to divide 0.88 divided by 130. Gives me 0.00677 moles of cobalt chloride. To get the moles of water, I'm going to divide the grams of water by the molecular weight of water, which is 18. 0.74 divided by 18 gives me 0.0411 moles of water. The next step is divide by smallest to get ratio. My smallest number of moles is 0.0067. That's going to be 1.00677. Gives me 6.07, which is pretty close to 6. I know that my ratio of water to cobalt chloride is 6:1, giving me a formula of COCl2 dot 6H2O. If I were naming this, it'd be cobalt 2 chloride hexahydrate. You won't need to worry about the names, but if you hear it, that's what it's referring to. You will always have a whole number to 1. This is not a case where you'll need to multiply by everything by 2 or everything by 3. It should always be a whole number to 1.